All right, so this sequence of videos will be on explanation in science. Now, why are we talking about scientific explanation? Well, remember that the goal of a scientific theory, or a main goal at any rate, is to explain some target of explanation. So we need to know what it is to explain and what a target of explanation is. So here's what we'll do. We'll first sort of give an intuitive sense of what we have in mind when we talk about explanation and introduce some terminology. Then we'll look at three prominent models of explanation in science. So first up, why is it we're talking about explanation? To be clear, sometimes scientists aren't interested in explanation. Sometimes scientists just want to describe how the world is. So for example, I could in some sense be doing science if I said there's a tree 50 feet in front of me, there's a trampoline 20 feet to the left of that, and so on and so forth. If I just describe what's going on. This is sometimes, if you hear about descriptive statistics, to some extent, that's what you're doing. So if I say half of the people on Iowa State's campus are male and the other half are female, or approximately half are male and approximately half are female, because there may be some other categories and there also may be some more of one group than the other. But at any rate, if I say approximately half are male and approximately half are female, I'm just describing the world. I'm not yet doing anything beyond that. But clearly, scientists typically aim to do more. They aim to predict what's going to happen, control what happens, and what this means here is to intervene in the system in a way that produces some outcome predictably, and explain what has happened. That is, tell us why things have happened the way they have. Now, we're focusing on explanation because prediction and control are fairly clear. Now, I just want to be very clear about this. It's not that it's trivial what prediction is or what control is. It's just that you hopefully have a pretty good grip on each of them. So to predict an outcome is to say it will happen, and to control an outcome is to intervene in a way that produces an outcome that you intend. We have talked a lot about theories predicting evidence. So I've said a theory predicts evidence, or when we talk about the probability of an observation given a theory, you can think of us as talking about how strongly the theory predicts the observation. When we talk that way, we're talking about an objective relationship between a theory and an observation. That is, we're treating prediction as a relationship between a theory and an observation. I want you also to realize this, and this will be the one thing I say about prediction. Realize that you can also think of prediction as a relation between a person or a group of people and some observation. So instead of saying my theory predicts this observation, which is something I can say even after the observation has occurred, I could talk about a person predicting an observation. And then what I'm talking about is a temporal relation. I'm saying before the observation occurred, the person said it would occur. And the reason I'm drawing this distinction and mentioning this is a theory should score a lot of points if a person says the theory predicts the observation before the observation is made. More so than it should score points if a person says, oh yeah, my theory predicted that observation after the observation was made. And the reason for that is straightforward. Remember, we've talked about how any theory can be made to fit with any observation, and any observation can be made to fit with any theory. What that means is, by tinkering with the theory a little bit, or by sort of analyzing the theory a little bit, you can make it the case or come to realize that the theory predicts some observation that you've already made. Well, that's not a very interesting way to predict an observation. It's much more interesting if before the event occurs, you say, this is what's going to occur. So think about it like this. If I said that before Trump wins the election, Trump is going to win the election, and then he does, then you might be impressed and say, hey, what theory allowed you to predict that? But if after Trump wins the election, I say, well, all my theories about politics predicted that, but I didn't tell you that beforehand. Well, you shouldn't be very impressed, right? There's something about actually saying it's going to happen before it happens that makes a theory that makes a prediction especially impressive. So I just want you to be aware that although you can talk about a theory predicting an observation in a way that's sort of atemporal, where it doesn't matter whether the observation has occurred or not, theories that predict observations before the observations occur and that explicitly are said to predict those observations before they occur should sort of score some extra points. But let's just set that aside, because here we're not talking so much about prediction as we are about explanation. And let's ask, what makes an explanation good or successful? Now here I want to just offer an intuitive standard. So in subsequent videos we'll look at particular theories of scientific explanation, but in this one we're just going to offer an intuitive standard. And in order to elucidate this intuitive standard, let's draw a distinction between what we're trying to explain, the target of explanation, which is the explanandum, or explananda if it's plural. I like this word because it lets us say one word instead of three. And on the one hand, and the explanans, or the theory, on the other. Don't like this word so much because we already have an ordinary English word that means the same thing. So what are the explananda for scientific theories? Typically they're particular events, like X winning an election. Or they're generalities, repeatable patterns, like men tend to be taller than women. What are explanans? Well, we've already decided we're going to treat theories as propositions that, if true, would explain some target of explanation. Remember, we also said you could treat theories as models or classes of models, but we're just not talking that way. What are these propositions? They're ones, again, designed to explain the explanandum. So here's the intuitive idea for what makes something an explanation. Suppose we have somebody here who says, why did the tire of that car blow out? And this person responds and says, well, it was overinflated and you hit a large jagged metal shard. That looks like a pretty good explanation for why the tire blew out. The tire blowing out is the explanandum, and this thing here is the theory. But in order to make it clear that this is a theory that would explain this explanandum if it were true, that is, in order to make it clear that this thing here is explanatory of this thing here, we need to say a little more. We need to make the theory a little richer. So let's make the theory this. The tire blew out because it was overinflated, the driver hit a large jagged metal shard, and overinflated tires tend to blow out when they hit large jagged metal shards. This looks like a clear explanation for the tire blowing out. Why? Now here's the intuitive standard. If green accepts that what maroon says is true, okay, that is, accepts the theory, which is stated in purple, and the premises, which are stated in brown, then green should stop saying, why did the tire blow out? So that's the intuitive standard. For any theory T at explanandum E, T explains E, if and only if one who accepts T, or T is a potential explanation for E, if and only if one who accepts T and relevant background premises should stop asking why E is true. Another way to think about it is like this. Imagine you go into the doctor and you say to the doctor, why am I coughing? And the doctor says, well, you have the flu, and the flu tends to produce coughing. It would be flatly irrational for you to say, yes, I agree I have the flu. Yes, I agree the flu tends to produce coughing, but why am I coughing? Right? If you accept what the doctor says, then you should stop asking your why question. That's a sign that what the doctor says explains what you wanted explained. In this case, you're coughing. Let's look at a contrast. Suppose somebody says, why can birds fly? And this person says, because they have beaks. Well, green can perfectly reasonably say, yes, I agree that they have beaks, but that doesn't answer my question. Why can birds fly? So green can say, yes, I agree with your theory, and then repeat the explanandum and say why. That's perfectly rational. And that's a sign that because they have beaks doesn't explain why birds can fly. By contrast, if maroon says, well, birds can fly because they have wings, and fills it out and says, and things with wings tend to be able to fly, provided they're light enough weight, and birds are light enough weight, and so on. Green won't be able to say, well, I agree that birds have wings, I agree that things with wings can typically fly, provided that they're light enough and the birds are light enough, but why can birds fly, right? That would be irrational. Okay, so that's the intuitive standard for being an explanation. In the next segment, we're going to look at one option for a specific view of what makes a scientific explanation acceptable. Okay, we're going to stop this segment there.